So, good morning. So today we'll repeat what we have done yesterday. So I have just added one part 2 to this one because yesterday we couldn't complete the discussion. So consider this as a lecture 32 and 33. So our numbering is correct. Okay, so we'll go very quickly and we'll have some time at the end, right? And please feel free to ask questions. So we have been discussing this topic for almost 2 classes. I will have to think through what are we trying to do in networking, because you understand this one, then later on, later some higher layers, like in the transport layer we use TLS and HTTPS. Concepts are very similar. In networking in general, when you want to secure your communication, you have just 2 ways of doing it. Okay, because in between the internet is insecure. Okay, whatever you send at one end can be visible to others, right? Because IP packets don't have anything for security. So now what will happen is that if you want nobody in between, like Mallory or Eve or Trudy to see your contents, you only way that is left out is to encrypt your packet. What can you encrypt? Your IP packet, right? So this is your IP packet if you encrypt. Now, if you encrypt fully, including its header, like which contains source and destination addresses, then of course packet cannot go. Okay, so there are 2 ways of encryption. First is that let the header as it is in plain text. So let the header as it is, and then put an additional field for which will tell you what kind of for example, in case of authentication, what kind of authentication you're doing, etc. And then authenticate the whole thing, and and then put the authentication result somewhere in this. So only thing I wanted to say is that if this is a, say, TCP packet that comes inside IP packet, this will remain in plain text, but it's MAC value or a hash value for authentication will also go, which will put it here, and will go to other end will just see that and will come to know is a packet of, say, AH type, and then it can check whether it has arrived correctly. So this is only for authentication. So there's a first way is that keep header in plain, same header that you have received from top for IP packet. Keep the same header, add an additional field, and then let this be also in plain text without encryption, and then send it and calculate for authentication. So there's a one simple scheme, right? Other scheme is that you want to also encrypt the header. So this IP packet, this header, and then this the content body, you encrypt everything. Then obviously you can't send it, right? It requires source, destination, and a lot of other things for routers to process. So what you do is that put this inside another IP packet. Okay, this will go here. And of course, you need additional fields to tell the recipient what you have done here. Okay, so how can the recipient decrypt it? And how can it do authentication check, right? Because you can do encrypt and authentication. But so you have to put this packet inside encrypted form, add additional field here and here, and then add a new header. When you say new header, why do you need new header? Because it has to go somewhere. Okay, now your destination node is behind the server, right? Or VPN server, etc. Then or gateway. Then this address would be of gateway, and gateway will do all the processing, IPSec processing, and remove this packet and send it to the destination machine in the plain form. That's one way. Other way is that if IPSec processing is happening in the other machine, at the end, then of course that machine can do the processing. Okay, now that's a very simple mechanism, right? So basically we have to do two things. Only two ways are possible. Is first is encryption for confidentiality, and second is authentication. Now the question, authentication means that now we are not talking about of course when you use VPN, you'll have to do other kinds of authentication like user ID and password, etc., right? Okay, so here we are talking about the MAC, message authentication code, which is hash on hash. That's a keyed one. Use symmetric key. It means that you calculate for IP packet MAC value, HMAC value, and then sign it with of course, because the MAC, so hash value is to be signed with some private, so some key, right, which is shared key. So basically, either we can use encryption and we can use authentication using or integrity check using HMAC. So these are the two very fundamental things. Now we are going to do this in combinations. Whether you want to do only encryption or whether you want to do only authentication, or you want encryption and authentication both, right? Okay, so this makes two schemes. A is called AH scheme and in ESP scheme. AH is only authentication. Then you can send everything in plain, okay? And ESP, which says encapsulated one, which we discuss here. Okay, these are the two schemes main, right? And then we say that where all this can go. Okay, whether it's from end machine, end laptop to another end laptop. That's one way. Second, you say that my laptop doesn't really need to bother all about that. For example, I have, okay, my organization is here. Part of my organization is the main office, and this is some branch office. And I don't want hundreds of machines in my main office to create IPSec session. So I'll say between the two, I will create a tunnel. Okay, and then plain IP packets will come from machines in this part of the organization, and then this will do all the IPSec processing. So IPSec processing is only between two gateways. So these are just four common. So we have AH header, we have ESP header, we have end-to-end encryption, and we have between gateways. So we have between gateways we call it tunnel mode, and the other mode we call it transport mode, which is end-to-end. So these four define overall IPSec. Okay. Now the next thing is that how to find out between. There can be many sessions because IPSec session is like TCP session, right? It's a session. It's not like UDP. It's just a session. It's a connection. Okay. So there is a connection between two gateways. So there has to be connection has to be established, and understanding has to reach about various parameters. And what are the understanding that is to be reached? That's what kind of cryptos are to be used, what are the authentication mechanism, what is the key length, etc., and what types of protocols we are further going to use, whether we are going to use certificates or not, and all that, right? Now, in order to even have that understanding, because same understanding has to be there for a session, in order to have that basic understanding, you need to create first a secure channel. Okay, how do you create a secure channel on which you can send all these parameters? You can do Diffie-Hellman. Okay, so Diffie-Hellman becomes the first step to get a shared session key and then use that session key to do other things. Okay, what I've said is very simple, in very simple manner. So let's go ahead and discuss some of these. So we see that IPSec works on top of IP layer. So okay, so although because of gateway, use of gateway, etc., it's not visible to end parties. Okay, for application it doesn't matter. All right. So three things that we do is authentication, confidentiality. These are the two functionality that we try to achieve in any communication over insecure channel, that is over internet. Authentication, okay, and confidentiality. Okay, and of course key management. How because you need lot of keys, you need symmetric key which is shared between two entities, right, which we achieve through Diffie-Hellman. Now for certificates you need to generate private key and public key. Now once we generate public key, then this also, Alice needs to know Bob's public key, and so she has got to have confidence that the key she is using is from Bob, so she will need also certificate that Bob's key is genuine. Who can give this certificate? Who will create this certificate? Bob of course can send this certificate, but has to be certified by somebody. All right. Okay. So this is the concept. Okay. So first we try to do is between Alice and Bob, we create a secure channel using Diffie-Hellman. Okay, and on that, once this is set for a session, okay, then we use this channel to have security association exchange, because both entities need to know what kind of crypto to we use, what kind of, what are the other security parameters, how Bob will process a encrypted packet that is coming from Alice. So he should know that Alice is using a DES kind of encryption, and also he needs to know that this packet is of particular format, and then that packet also contains authentication information. Okay, and lot of other parameters that are required for processing that has to be exchanged. That we call it security association. So now once you establish this secure channel through Diffie-Hellman, then next step is that establish essays security association between Alice and Bob for one session, and then this exchange can start. So there's a process. All right. Okay. So let me just go to the end that we have not covered in the last class, and we'll go back and revise everything. And note that we'll subsequent algorithms that we'll study, I think we'll have time only for one more TLS. We will not go into this detail. Okay. So let me go to the end and then tell you, and then we'll come back and revise what we have done so far. So you'll get some idea of, okay. Okay, we are here. Okay, now first thing that is needed is that we need to establish a secure channel. Okay, but in order to also start a secure channel, what do you need to do? I mean, we say just do Diffie-Hellman. Is that simple? Can you start Diffie-Hellman from your machine to some other machine? Your machine, other machine will simply reject whatever is coming until unless there is some understanding, right? Okay, so there is a very specific protocol defined for this. Is called IKE. You can Google and find it out. Now this protocol is independent of IPSec. Now there are very few uses of internet key exchanges, so it has become part of IPSec protocol. Now this is a protocol for doing mutual authentication and establishing shared secret keys. Okay, now shared secret keys between two entities, okay, and is called IKE channel, or or tunnel. That's what we can call, right? And once this is secret channel established, or confident, which will provide confidentiality, etc., using Diffie element, then we can create IPSec security association using this. That's the next step. So the idea is that we should be able to create security association. It means that both Alice machine and Bob's machine, if we are doing end-to-end, or Alice gateway and Bob's gateway, okay, they will have same understanding that whatever packets Alice is, whatever packet Alice sending to Bob, it will use certain crypto, certain kind of encryption, and so on, right? So that's the step, right? So we'll see that. So now we can do this manually also between two machines, and it used to happen that machine at or gateway at Alice's end and gateway at Bob's end will this will be done manually through operators. So it will store all these parameters, right? What is SPI, security parameter index, source address, destination rate, what kind of protocols we are using, like ESP, what kind of encryption method we are using, what kind of authentication, like HMAC we are using, like MD5, because there are choices. What is the encryption key and HMAC key, etc. All these are to be set. Now this, of course, these keys are to be known at both ends, right? Bob, whatever Alice is doing, it has to be known to Bob. So doing manually for so many VPNs is impossible. Now impossible, because there are millions of VPN sessions that's possible, hundreds of VPNs. So instead of that, use this algorithm. Okay, this algorithm, which will automatically create security association at both ends, which is nothing but a relationship between the two. Okay. So there are two phases. First, as we discussed, is establish IKE, basically create a secure channel end-to-end. Is called IKE security association, which is different from IPSec security association. Now, okay, basically it's a confusing term, right? You just understand that we are trying to create first a secure channel in phase one, and on that we can create session-wise IPSec security association. Okay, so this diagram is, don't go into too much of details. I just want to give you basic concepts, and details, of course, you will have to find it out, okay, if you are interested. Okay, so the traffic comes, which needs to be protected. Okay, so now it's between two gateways. Let's assume this is a gateway and this another gateway or router. Okay, the first is that IKE phase one will create a secure communication channel. Okay, so it's between these two entities, there is a channel is to be established. That's the first thing. And then phase two is that in that IPSec tunnel is to be created. It means that both ends should know what kind of encryptions are to be used, etc. Right? All that we have discussed here, right? All these things must be known to both ends, right? So now this is called IPSec tunnel. It means that essentially IPSec SA, security association, must be known to both Alice and Bob. Once that is done, then traffic can flow. Okay, so the what now how to do this phase one, phase two, the details are given, and you can read it from any book. Of course, not many book will contain all the information, but many books actually don't go into details. Okay, so now first thing is that phase one we can see. First thing is that we is in the phase one we'll have to first we have IKE policy, right? Basically, this is this will say that what kind of encryption mechanisms we are going to. So basically, it's an interaction of crypto. What in even to have Diffie-Hellman one, okay, we have to decide. So Diffie-Hellman is just talking about key, shared key, but that shared key can be used in multiple types of algorithms, right? Crypto algorithms. So first is that that all that understanding has to be reached. Okay, what kind of crypto you are going to use? Say DES or whatever, or AES or something, right? What is key size, etc. Okay, what is going to be session time? Okay, it's a lot of other parameters will first this will negotiation will happen in open. Okay, it's a plain text. Okay, and then Diffie-Hellman exchange will happen. So now after that there is a shared key is available. Okay, and then using shared key and whatever we have understanding we have reached about crypto algorithm, etc. A secure channel can be established. Of course, there is a phase of kind of authentication here. Okay, so there's a part of phase one. Phase one does it creates a secret channel or a tunnel between two entities. Okay, and then phase two is essentially creating security association between Alice and Bob. Again they have to discuss what all what all will be there in their security association, like the one which we have discussed here, right? These ones. Okay, now this security association between Alice and Bob is just temporal for some time. So after some time session is over, then new security association can be formed and so on. Okay, any question? I'm not sure you are able to understand it fully, but you just need to understand basic thing, right? Any question? Who can tell me? Ankita Chan. Ankita, are you there? Are you able to understand? नहीं आ रहा तो just tell नहीं आ रहा. That's it. It's not. I understand there's a lot of complexity here, right? You just need to understand basic things, because protocols in networking world, each and every bit has to be interpreted correctly for communication to happen. Okay, now in VPN, etc., you can see that one company's VPNs are used at both ends, because that understanding between multiple vendors is still not there, while IPSec has been very precisely defined. Okay, so all right. So now let's go back and then revise the concepts again, and then we'll see if it makes all right. Okay, so this is where we okay, so IPSec is a framework. It does not give very precise way, or it's not very, it does not give 5 or 6 message exchange and say that you have to use only DES and you will have to use only digital certificates and so on. So forth is the way. Okay, it simply gives a framework, and then different vendors have to choose what they want to do. Okay, so of course there has to be first a key exchange. Okay, so key exchange is we use Diffie-Hellman. Okay, because once we use Diffie-Hellman, then we can create we can, the both ends can come out with session key, right? Which is secret session key. I mean, we have studied this in detail, right? Say K, both end will come out with K. So if Alice uses some algorithm, say encryption algorithm like DES, okay, of course the DES key, okay, that understanding that both are using DES has to be there, okay, but this session key can be used as a for encryption. So both end will know session key, and then whatever Alice is sending, Bob can decrypt it. In actually algorithm, we are not using directly the session key, but we derive this keys used by in DES etc. from the Diffie-Hellman key. Okay, nevertheless. So first thing is that have a session key, and then of course we are using for authentication MD5, which is HMAC. Okay, message authentic codes we use, and within that of course we are using MD5 for SHA, and then of course sign it with a private key. You remember it, right? And then for encryption we can use any one of these, DES, 3DES or AES, and then we can have now we can do choice of doing ESP, which is encapsulating type, where we put IP packet within another IP packet and encrypt. If we do we have choice of doing just encryption, we have choice of doing encryption and authentication. Okay, and then we have choice only of doing authentication, no encryption. Now, one exercise for you is that when you look at VPN you use, or VPN that are available for free, then see what kind of, while you may think that your data is confidential, there's a possibility that they are using just authentication and charging you, may charge or may not charge you money, right? All right. So we have seen that there are two kinds, ESP and AH, that we have discussed in detail. And this diagram tells you what is the relationship and how packet processing happens. Okay. Okay. So we have this security association that we have formed, that Bob will have, Alice, when sends message to Bob, how will she encrypt? What is her IP address? And so on and so forth, right? All this thing that comes in security association. Okay, and that's only for a session between Alice and Bob. That has to be there in a table, because there can be multiple such sessions, and that table we call it security association database. Okay, and somebody has to give index to this one, because when Alice is sending a packet to Bob and Bob is behind is using IPSec, then this will decide the packet that is coming from Bob has to be processed at Alice's router using some security association. Okay. Now, while Alice may be sending a packet to, say, for example, somebody else, and that may not require IPSec. So security policy. So this SPD is nothing but security policy database, which will look at packet coming from Alice and say that what is to be done, whether a particular security association is to be used with a Bob, or if message is going to somebody else, then don't use IPSec. Okay. All right. So security association we have seen may contain a lot of information like this. Okay. And when a packet comes from Alice, this is to be processed according to security association. So it will say whether ESP is to be used, encapsulating type, or AH to be used. All this information is known. So when Alice sent packets for Bob, This based on a security association or understanding, this packet will put Alice's packet inside another packet, and then if it is ESP, then encrypt this and put authentication data, and put another IP header and send it. So all these things that are to be done is according to this security association. All right. So the flow is as follows, that there is a whole architecture includes security policy database. Then when Alice's packet comes, it comes through policy database, it looks at IP address or whatever details and decides what security association is to be used when she's communicating with Bob, and all that processing will happen, and then packet will finally go over internet. Okay, all right. So I will not go into details. This gives same diagram is here. Okay, this defines a flow. Outbound processing, it means that it's going from Alice to Bob. And note that this relationship is only in a one way. Okay, it's not bi-directional relationship. So there is one security association when Alice is sending to Bob. Say we call it a security association 1, and when Bob sends it to Alice, then it's different security association. Okay, so we are talking only one. So outbound means that when it's going from sender to recipient, okay, or Alice to Bob. So IP packet comes, Alice's laptop generates IP packet, then is it for IPSec? Should we do IPSec or not? And if so, what policy is to be selected? Now this is done in security policy database, and from that it can find out what is for, if it's going for Bob, what is the SPI, security policy index, and this index will give you all about security association. Okay, what kind of encryption, etc., etc. Okay, and then a new packet is created, and in that information is kept. That includes also SPIs, such that Bob's machine can process the packet. Okay, any question? Someone needs to be on mute. Okay. Naga, Tanuja, can you put yourself on mute? Okay, all right. Okay, we'll try to. Okay, and this is the way, once Bob's machine receives a packet, so this packet is something like this, right? I mean, let's assume for ESP, it has encrypted packet, original packet that Alice has created, and a header, a new header, and then some information. Okay, and something at tail end. Okay, so now this packet has come, and then she has to understand what to do. Okay, what will she do? Okay, now in this field, there is something called SPI, security policy parameter index. So her machine will look at SPI and go to security association database and will know the details, what kind of crypto or what all keys are used, etc., because keys are also stored for decryption, right? Okay, and then it will go to policy and see if packet was properly secured. The policy is the policy being followed, and if yes, then then it can be processed, right? Because all the information is available right here in the database. What kind of crypto she is using, what is the keys, what are multiple keys that are there, right? Okay, so then this processing can happen, and Alice, Bob's machine will receive the original IP packet which was sent by Alice. Okay, and we have seen that there are two protocols, ESP and AH we have not discussed. So we have seen that this is the original IP packet that Alice's machine generates, Okay, she encrypts all this. Okay, and then this comes under another packet, IP packet. Okay, and then of course this header which contained the destination address also got encrypted. So new header is to be attached. Okay, and then there is information about what all, how Bob's machine must process it. So there is SPI, security parameter index. Okay, so that Bob's machine will know, when Bob's machine receive this, will look at database, and then through this index will come to know what all will be done to process this. Okay, and of course there is something for machine will also look at authentication code that is generated by Alice's machine and then process this. All right, so it's simple. And we have seen there are two modes. Transport mode, which is directly Alice's machine is talking to Bob's machine. So Alice's machine generates this IPSec packet, and Bob's machine should be capable of handling this. Okay. Now, alternatively, we have a mode which is called tunnel mode, where end users are not supposed to do all this. End users, because you are working in a big organization, and then you don't need to generate, there are millions of packets that are going from one part of the organization to another part of the organization. So you say they let gateway handle this. So your machine or Alice's machine will send the plain simple IP packet, and then gateway will process that. Okay, so we have a tunnel mode which is between gateway to gateway, and transport mode which is end to end. Okay, all right, and we have seen how we process this. The Alice's machine generate this. Okay, that becomes part of the packet. Okay, and to that IP header is added, and new IP address header is to be added. Okay, because this is encapsulation. So we see in this. Okay, wow. So in this diagram we see this. Okay, this IP header and data comes here. That gets encrypted. That's encrypted. Okay, and then we attach. Okay, sorry. This sorry, this is data, and this all get encrypted. This is the original packet encrypted, right? Now where is the encryption information is there? In ESP header we have SPI, which we are sending to Bob. So Bob will look at table and know what kind of encryption is done. And also there is a sequence number to, so somebody in between cannot generate that. So, all right, and basically to avoid replay attacks. Okay, so ESP, now question I'm asking is that now why ESP header is also not encrypted? Anyone? Just think.
Because then we won't know the SPI.
Yeah, so no, very good. Bob's machine cannot find out how to process it. All right. So this we have seen. So very simple. Okay. Now this, so in this mode, tunnel mode, Alice's, there is no IPsec between Alice's machine and we call it firewall also. What we are studying is actually firewall or gateway. And then there is a IPsec tunnel between two machines. All right. Very simple. So we have seen that this is a original packet, and then we are attaching to this ESP header or AH header. Of course, AH we have not discussed, and IP header, and of course here we have not shown is something at the end. Okay, like something that we have seen. Okay, just a minute. Yeah, here ESP or ESP authentication. All right, so this concept we have seen already. All right, now this shows how encapsulation is done in case of ESP, right? I mean, so you take this packet. Now note that something very interesting is happening is that protocol type field is changing. Okay, now this packet will go as it is inside the bigger IP packet, right? Because we are doing encapsulation. So here this thing will remain same. It will remain TCP only. Okay, all right. But the new header that we are adding in that protocol type cannot be TCP, because now Bob's machine needs to know how to process this, because until you tell the machine that this is IPSec packet, and that too of type say ESP, it will not interpret all the fields. Okay, it will not. So the moment it looks at this thing, then it will know this is IPSec packet, and then it will start processing accordingly. Okay, so the outer header of outer envelope or outer IP packet will contain protocol field corresponding to the protocol that is being used, which is IPSec protocol, ESP or AH or whatever. Okay, simple. All right. And transport mode we didn't study in detail. So basically in transport mode, aim is only to do authentication. So everything is, otherwise everything is in plain text, right? It's not encrypted. So you take the IP header as it is here, okay, and payload as it is, and then attach IPsec header, which will contain authentication information. Info like, what kind of, okay, so it's the, like, what is HMAC code, etc. All right. So this is transport mode. If you are, wow, sorry, I'm sorry, I just messed up. Okay, I'm not talking about AH. I'm so sorry. I'm not talking about AH. I'm talking about transport mode. I don't know why I got confused. So transport mode is between the Alice and Bob. Alice's machine and Bob's machine. And Bob's machine, right? Directly, this even if there's a gateway in between or router in between, of course there will be, but it's between two entities. And now this is end to end. So there is no new IP header is required. Okay, and it can use any of the two protocols, ESP or AH. So we what we do is that we take the same IP header of original IP packet. We keep the same IP packet, and then have the payload. Okay, and then we attach IPsec header. Okay, now this can work in ESP mode or AH mode. Okay, so now here it shows how it can be done in ESP mode with transport mode. Okay. So what are we doing here is that we keep the original IP header, okay, attach ESP header, and then the original packet comes here, then attach ESP tailor, and then ESP authentication. Okay, all right. So all is and this is encrypted. The one which is shown here is encrypted, and which is shown in white with white background is non-encrypted. Okay, all right. So this is a different way of communication, which is end to end. Now, since it's end to end, then IP address, original IP address, etc., cannot be encrypted, and then rest of things can be encrypted. That's possible. ESP header again is not encrypted for the same reason, because recipient machine needs to know SPI. All right. Any question? Okay. All right, so this is what we have. So we have discussed earlier it for tunnel mode. Now it's similar thing. It happens for transport mode. Okay. Now here, there's little change here, right? I mean here, header remains the same. Okay, this header is same. Okay, accepting that now here the protocol field is to be changed, because now the received packet has to be interpreted as a ESP packet or encapsulated type packet, right? It means that packet. Okay, so now the question that we can ask is that, say inside original IP packet there is a TCP packet, and this protocol field actually tells recipient that how to process rest of the packet. Okay, so that rest of the packet contains another packet which is TCP packet. Now here, how will it come to know? Because you are changing here to ESP. Okay, then there must be a field here. Okay, so there must be a field here in ESP Taylor, right? Which will tell what is going to be protocol type or next header type. Okay, here it is to be defined as TCP. It means that now all this is to be interpreted as a TCP packet. All right, it may sound a little confusing because we have gone through it very fast. Okay, all right, and this we have already discussed. Okay, now I suggest that please go through the lecture, and then there are some how I key phase one, all these steps happen. What are different steps is shown here. I didn't want to discuss this because it may be too much of confusion, etc. Right? So please go through it if you want. But there will be, just remember the basic concept. That's it. Okay, and we are going to apply the same concepts in when we'll study transport layer protocols like TLS. Etc. Remember that just two things: that encryption. Now it is streaming encryption, so we'll have to use symmetric encryption, AES or DES or whatever, and maybe more efficient ones. So symmetric key encryption. That's first thing that we need. Now we need to also have authentication or integrity. What all we can use for that? We can use HMAC, maybe just hash. I don't know, some hash. And for that we need the moment you say MAC, then we have to have private and public key. Okay, then we need to generate that too. How do we generate that? And then how we communicate public key, etc. That there's another protocol exchange could be there for that, and so on, right? And then we also need certificates. We may also need digital signature for non-reputation if it's required. That's all. This is just interplay of this. How do you do this? As a question. I mean, even an HTTPS, same thing. The protocol or the message that's going from your end to server has to be protected right in the beginning when you're running HTTP protocol, right? So right there you do encryption. Or in order to do encryption, then other end also needs to know what kind of encryption you're using. There must be some understanding. And when session should stop and what is the time and all that will come also in the protocol. So that's it. Okay. All right. Thank you.